As Intel and AMD-based mini PCs are getting ever more powerful, a new breed of ARM core-based minis is conquering the world. Though most of ARM-based designs still lack powerful graphics acceleration, their processing power is slowly matching and even surpassing Intel and AMD processor-based mini PCs. Apple ARM-based mini desktops have already paved the way with their numerous processing cores, powerful graphics, and even an artificial intelligence accelerator core. However, these are desktop-only machines and they lack custom extension ports and hardware support for various communications protocols, which make Raspberry Pi and similar designs much more appealing to home developers. Absence of Raspberry Pi 4 successor enabled other open hardware mini PCs like Orange Pi 5 to quickly gain popularity. But unproven yet powerful designs still need years to gain developer community's trust and support and assure availability of versatile and numerous open-source software. What would an ideal future Raspberry Pi design look like? Current Raspberry Pi is usually a mini PC desktop like Raspberry Pi 3 or 4, or a pure microcontroller board without an integrated graphics processor like Raspberry Pi Zero and Raspberry Pi Pico. A compute module is a third kind of Raspberry Pi, which offers a much greater flexibility. Raspberry Pi Compute Module 4 can be used with a variety of carrier boards that already feature PCBus and external Wi-Fi and Bluetooth antenna connectors like Orange Pi 5. Some carrier boards are even powered from a PC-ATX power supply and also feature an inbuilt 3-volt battery to support a real-time clock operation during a power down. Shipped CAIOCM 156 all-in-one desktop carrier board, for instance, supports SSD drive. 2. DeskB Super Carrier Board, on the other hand, enables you to build a Raspberry Pi multicomputer with up to 6 Raspberry Pi compute modules. The modules run in parallel and they are internally connected via 1 GHz Ethernet. The first module also functions as a control center and it is the only one to have implemented HDMI graphics connectors and 2 USB ports. The rest computing modules only serve as computing nodes with up to 8 GB of RAM, an SD card slot, and a PC connector that can be used to plug in a fast SSD drive. Raspberry Pi Hub will include many of these features such as PCBus connectors as standard. It will also feature 4 more powerful ARM Cortex processor cores. Compared to Apple's system-on-chip, Raspberry Pi 5 system-on-chip is also expected to feature an advanced graphics core with doubling the maximum graphics resolution to it. Raspberry Pi 5 is expected to be available no sooner than 2024, but Raspberry Pi 5 compute module is not expected until 2025. Watch Inside Raspberry Pi 5 video to learn more about forthcoming Raspberry Pi 5. Raspberry Pi 6 is not expected to be available sooner than the second half of 2025, but Raspberry Pi 7 and subsequent models should follow every 1 to 2 years afterwards. Even if Raspberry Pi 5 brings significant graphics acceleration, Raspberry Pi 6 will certainly need a much more powerful graphic core and an artificial intelligence accelerator core. Raspberry Pi 6 is also expected to support a faster Wi-Fi standard and it should feature 4 or more USB-C ports. Remaining USB 3-type ports would be primarily used to connect data keys. Raspberry Pi 6 should feature 2 or more PC ports and a second micro SD card socket. More than 1 PC ports would offer a much greater flexibility. An active cooling will likely enable speeds up to 3.5 GHz or even higher due to a Raspberry Pi 6 small size. Energy consumption at lower than 3 GHz speeds would significantly decrease, and this would enable use of artificial intelligence methods on drones and robotic vehicles. Future Raspberry Pi models like Raspberry Pi 7 that are expected no sooner than 2027. They would be based on system-on-chips with an order of magnitude more transistors than Raspberry Pi's system-on-chip. They would support a variety of PC graphics cards and artificial intelligence modules from different manufacturers. Ever-increasing transistor resolution would finally allow addition of new processor cores with much larger caches and more than 1 powerful graphics core to support check resolution and higher onto monitors. Alternatively, Raspberry Pi 7 might only be available as a compute module 7 to be used with a variety of carrier boards. An additional fast memory bus would enable graphics processor implementation on a carrier board instead of in a system-on-chip. These would offer a maximum adaptability and flexibility for desktop, control, and data processing variants of Raspberry Pi 7. Thank you for watching. Click like and subscribe buttons if you liked the video. See you in the next video.